How many of you have used Kubernetes before and run workloads on them? And how many of you have practiced in CI/CD? Okay, a few. How many of you have used Jenkins? Pretty popular. And anything else? All right. Okay, so today we're going to start off by covering some basics, and we'll jump into a new project we call Tecton. We're here to talk about the next generation of CI/CD, and we think it's time for CI/CD to take a huge leap forward. And we feel the key leap is cloud native. And everyone uses the term cloud native. However, a lot of people don't understand what it means. Often, I don't either. What we mean to be cloud native is open source, microservices in containers, and those containers to be dynamically orchestrated, where you can have better resource optimization and utilization. So we'll start with what are containers. Often, when you're shipping applications, you'll have a web of dependencies, system-specific code, and it can be a mess. So we introduced containers. And containers, instead of just distributing binaries, we package up the binaries with all the dependencies and the configs, and we ship them into a single object, making it easy to run anywhere. We'll start with what is Kubernetes. With all these containers, we have quite a few to run, and managing all these containers can be very hard. And so this is where Kubernetes comes in. Kubernetes is a platform designed to orchestrate the containers. So you tell Kubernetes how you want to deploy your service, and Kubernetes deploys it. If you lose a machine that your application is running on, then Kubernetes will recreate that container that was lost, and your code is still just as reliable. With Kubernetes, you abstract away the underlying hardware, so you don't have to worry too much about the computing or the storage when you're trying to run the container. And so this is what cloud native often ends up looking like for most of us. Containers running microservices in Kubernetes, and these containers are again dynamically orchestrated and optimized for resource utilization. So what is CI/CD anyway? For those not familiar with CI/CD, it's a set of practices for how code gets built, tested, and deployed. Continuous integration pipelines are often kicked off during a pre-submit, and it figures out which code to merge and which branch. After that, the continuous delivery will figure out where it wants to deploy it and which environment to deploy it on. So we often find that this looks like this. Containers that are reproducible and reusable. They're dynamically orchestrated, which means increased reliability, and this dynamic orchestration and being able to shift them between machines has less resource utilization and much more portability. The challenges we find previously with cloud native are often still the same. They may be in a different form. when we say that we want to put everything from monolithic applications into microservices, you'll find that there's more complexity in managing all those different microservices. And the terminology is often quite confusing. Every different tool calls something differently, and they all often do the same thing. And there are a lot of tools. Every week there's a new tool, and I can't keep up with them, and the industry can't keep up with them, and often it can be very hard to figure out which tool to use. It's great to have many choices, but this complexity and frustration and fragmentation doesn't help. So when you break down these different CI/CD services, they often find that they come to the same components: workflows, tasks, and core services. For instance, the workflow has scheduling, and the task has unit testing or building, and the core services have like source repos or artifact store, etc. At Google, we wanted to take a step back and try and simplify the CI/CD the same way we did with Kubernetes, by collaborating with industry leaders to create cloud-native APIs for the container orchestration in the CI/CD pipeline. Basically, the goal would be to build, test, and deploy the code anywhere using these guidelines. And so we came up with Tecton, like a robot cat, something like that, where this is open source, cloud-native building blocks for building CI/CD systems. Even though Tecton runs on Kubernetes, our goal is to have it run on any cloud: GKE, multi-cloud, hybrid cloud, tribrid cloud, you name it. Tecton started off as a Knative build project, and people really enjoyed being able to build on this Knative project, and so they wanted more. They wanted the pipelines, they wanted to add different steps in than just building, so maybe unit testing or something else. As enthusiasm for the Tecton project grew, they branched it out to its own GitHub org. The vision for this project is CI/CD building blocks that are composable, declarative, and reproducible. We want to make it super easy and fast to build custom, extensible layers on top of these building blocks. Engineers can take a project's entire CI/CD pipeline and run it against their own infrastructure, or just take some pieces of that pipeline and run them in isolation. The more vendors that support Tecton, the more choices users will have. And they'll be able to plug together features from multiple vendors using just one pipeline definition. So currently, Tecton has contributors from Google, CloudBees, Red Hat, and IBM. And we welcome any contributors. So our first building block is pipelines. And we'll dig deeper into that now. So a Tecton pipeline is a custom resource definition in Kubernetes. And Kubernetes CIDs help you define your own resources to use and your own custom tools. So at the moment, Kubernetes has resources like pods, deployments, and services. CIDs allow you to extend Kubernetes by adding your own additional resources and creating services called controllers. And these controllers run in Kubernetes and act on what your custom resources need. So what CIDs have we made? The first CID is a step. This is the most basic. And this step looks very much like a Kubernetes container spec. You have your image and some arguments and generally how you run a container. The next CID is a task. And the task has many steps. And now all these steps could be things like the first step might be pull my code from a special place. The second step might be to build the code or test the code. And the third step might be to output it in a certain format or another image or container. With that, we can put together tasks using our next CID, pipelines. Pipelines let you express the order of these tasks that they run. You can run them sequentially, concurrently, whenever you need. And often these tasks will run on different Kubernetes nodes. With pipelines, you can connect the outputs of one task with the inputs of another. This is an example of a pipeline. You can see here that the setup and test environment, build images, and run integration tests are running sequentially because you can do all those things together. And at the end, the pipeline deploys the code, and at the beginning, they lint and do unit tests. So you can build complex graphs doing this. When we create pipelines, when we create these CIDs, you want to be able to use them again and again. And to actually invoke these CIDs, you have a run. And now we have pipeline runs and task runs. These are instances of pipelines and tasks. In order to run pipelines and tasks, we need to provide them with runtime information, like what image registry to use, what Git repo, or anything else. And we do that using a pipeline resource CID. So the 5 basic types in Tecton are tasks that are made up of steps and pipelines that are made up of tasks. Task runs and pipeline runs, which are instances of those tasks and pipelines, and pipeline resources, which tell the runs what resource to actually execute against. The great thing about this is you can decouple the runtime information from the static pipeline, and task definitions gives us a lot of power. Now we can take the same entire pipeline, which we'll use to push to production, and we can run that on pull requests before we submit them, and shifting even further left, we can run the same pipeline against a contributor's own infrastructure. At a high-level view, this pipeline looks like this. A user creates a pipeline and a task in Kubernetes, and they stay there until they're needed. And when a user wants to invoke them, the users create runs. A controller process that's running on Kubernetes will pick up the fact that these runs have happened and create the containers that are necessary on the nodes. Last but not least, Tecton is now part of the new Continuous Delivery Foundation, an open foundation where we can collaborate with industry leaders to provide best practices and guidelines for the next generation CI/CD systems. The current projects that have been donated to the foundation are Tecton, Jenkins, Spinnaker, and Jenkins X. These are our current members. if you want to help or join the foundation, I encourage you to look at this link because we welcome every contributor. This is the current roadmap for what we want to do for Tecton, and this includes event triggering, conditional execution, and more. And the takeaways here is that if you want to contribute, like I said, here's a link, and as an end user, you can see Jenkins X. All right, so as you can see, Jenkins and Cloud Bees and Jenkins X, including and also Trigger Mesh, have started to use these Tecton cloud native resources. It's very easy, and I can go back a few slides. Oop, this is a bit broken. All right. Well, it's very easy to get started. On the earlier slides, I showed you a link to the GitHub repo right here. And there's a very easy Hello World example. So I suggest you can just go to the Google Cloud console, start up your own Kubernetes cluster within a few minutes, and try and run their Hello World example. But in the spirit of not keeping you all here too long for the last session, I'll finish here. So thank you.